Hey there, welcome back to another video. So in this video, we'll be doing some more data analysis along with visualization. So for visualization, we'll be using Matplotlib, Seaborn and Plotly. And our data analysis will be going through this NumPy and Pandas. So we are using our existing dataset that we have already used in previous video. Now this dataset contains all these columns that we have already seen in previously. Now data types are integer, float and object. So now our primary focus is that numerical data columns may contain outlier, right? So we have already seen that CKMB and troponin does contain outliers. You can see that using this box plot of CKMB, that these are the outliers that present in the dataset. So what we can do, first of all, we're going to detect the outliers first. Then we'll be trying to remove the outliers using clip function. So in order to do that, I'm going to use IQR method, that is interquartile range. So we'll be setting some limit, upper limit and lower limit for outliers. So I'm going to need all these numerical columns. So I'm going to use a new variable that's going to store all the numerical columns as a list to use in for loop. So I'm storing that, giving this variable all the list information here. I'm using df dot select d types, and I'm going to take the numerical data only, that is our np dot number, and I'm taking this data from columns and I'm converting this data as a list. So I'm using toList function to convert this output of this variable as a list formation. Now let's run this. So now if I just print the num calls, it's going to give me all the column as a list. So you can see all the numerical columns has been converted as a list. So now we are good to go. We can use this numerical variables in a for loop for IQR method. Now for call in numCalls, I'm going to use quantile1 df call would be quantile of 0.25, and our q3 would be df call 0.75. Now we can derive the IQR here. Interquartile range would be q3 minus q1, and we can also get the lower and upper limit from this using lower as a q1 minus 1.5 multiplied by IQR only. Then I can get the upper also using same IQR, that would be q3 plus IQR 1.5 into IQR. And now we can get the outliers from here. I'm gonna try to make a outlier data frame so that we can see all the outliers. In order to build the data frame, I'm gonna use df, and df would be df column. So I'm gonna need a bracket over here also. Df call lower less than lower, and also I'm going to use a pipe function to union this df call greater than upper. So basically anything lower than the lower limit, anything greater than the upper limit will be calling as an outlier. So let's run this. I'm going to call this outlier data frame in another cell. So here is the total outlier dataset. All of these are outliers. So our dataset contains 250 rows of outliers. All of these are coming as outliers. So there is a huge amount of outliers present in our dataset. We won't be able to remove this amount of data from the dataset because that would be malpractice, right? So we can do some clipping. So let me just copy this. I'll be using this. I want to need this for clipping as well. Df call here. I'm going to clip this into lower, upper. Now I'm going to use some new data frame. And for that, I'm going to just copy this. Now let's run this. Yeah. Now let's see, do we have any outlier or not? Okay, so all the outliers has been gone. We can check also the data set shape. It should be exactly 13 19 rows and 9 columns exactly, because we are not deleting any of the data points, we are just clipping it. See, our data set is intact, no elements has been removed, so that's good to know. Now we're gonna try to see the visualization of outliers using boxplot. See, all the outliers has been gone from the data. Now this is showing this KMB. Now we can also check for troponin as well. Troponin. So for troponin, it's also looking fine. So our earlier investigation, we have seen that troponin and CKMB increases for positive results. But previously we have found that there is lots of outliers, right? Here you can see all the outliers is there in the dataset. But since we have used the outlier removing technique using CLAPE and IQR method, our data is looking much more clean and it has more meaning than the previous analysis. So that's how you remove the outliers in the dataset, if you have outliers, I mean. So let's do some distribution analysis using boxplot. I'm going to use boxplot visualization for all the numerical columns. So for call in numcols, plot to be our figure. Plot figure would be our fixed size. Fixed size would be, I'm going to give fixed size of, let's say, 5,4 define, 5,4 define. Now I can put the SNS. So you can use for loop for multiple visualization as well. So I'm going to use x for df dot call, and I'm going to use dot show. Let's see what happens. Okay, now we are getting all the box plot for regarding all the numerical data. So this is age, gender, healthcare, heart rate, and systolic blood pressure, diastolic blood pressure, blood sugar, CKMB, troponin. So all the outliers has been removed from our dataset using IQR method and CLIP. Now what we can do some histogram analysis as well. Now let's see what we can do for histogram. I'm going to copy this. I'm going to change this box plot. Histplot. So now it's fine. It's generating the histogram as well, along with distribution curve. So this is our age distribution. So most of the people are our middle age category. As we can see, this is the count for them, which is coming to the 140, and we have only two gender rights. This is how we can analyze your distribution of your data as a numerical distribution using histogram along with boxplot using for loop. Now you can also use some more advanced pandas formula like PD cross tab. Let me get the data once. So this is our data, right? And our data contains one categorical column and it's this numerical column, right? So PD cross tab, let's do PD cross tab and give this our gender along with df result we find. And behind the curtain it's using some group by function and it's giving me the value, grouping the gender count on the basis of result. So that's the PD cross tab. Now we can check the heat map. Okay, since we have already stored all the numerical data inside this num columns, let me get it first. Yeah, so all this numerical data has been assigned in this variable of num calls. So I'm going to use this num calls to get a correlation matrix. Num calls, right? So let's give the correlation to store the value of correlation matrix and put it under this num calls needs to be put it under df, and I'm going to use this correlation function to get the correlation matrix. Let's see what happens. Yeah, done perfectly fine. Now I can call upon the correlation matrix. So this is the correlation matrix that we are getting, and I'm going to use this correlation matrix to generate a heat map. So for that, I'm going to use SNS, that is Seaborn. So SNS heat map would be like this correlation. I'm going to use this correlation variable inside this heat map, and I'm going to use annotate, and that means annotation needs to be true. So it's going to label the data points inside the heat map, and I'm going to also use CMap, that would be our color. I'm going to use cool one would be fine. So cool one is basically red and blue color, and FMT would be 0.242f. That's basically how many digit you want after decimal point. So I will be getting 2 digit after the decimal point, and I can call the plot show here. So this is the heat map. Diastolic blood pressure and systolic blood pressure has some kind of relation, which is positively coming as a 0.6. Now we are done with heat map. Now let's do something more. We can do some interactive plot generation using Plotly as well. Now to do the graphical representation through Plotly, we're gonna need fig, that will be our figure, and we need to use px. Since we have used px as alias for Plotly, we're gonna use box, since we are using a interactive box plot first. So for that, we're gonna use box as a box plot, and I'm gonna assign the df, and x will be our, I'm gonna use result first. For x-axis will be result, and y, let's say I'm using age here, just to show you an example of it, how to draw the graph first. Then I would assign some title if you want. You can skip this also if you don't want. I'm just showing the one example only. That will be our age versus results. Now we can give the color also if you want. You can give color of your choosing. So I can give color like result based on result, and like you can choose the palette of color. So I'm gonna use color discrete sequence would be px dot colors, and sequential validity would be fine. Sequential validity. Now let's call the fig show. So it's taking some time. Yeah, so this is the interactive graph that I was talking about. So this is the negative and this is the positive for age. You can get all the interactive data points using this Plotly. So that's the beauty of Plotly. We can do some more analysis. So we'll be doing some scatter plot using Plotly here. So I'm going to use px.scatter. gf x will be our CKMB, and y will be our troponin. So this is our scatter plot. So both axes will be our numerical in nature, and let's keep the title. Color will be our result. So color basically hue, just like C1 we are using hue. So color is here is basically acting like a hue. So our color will be based on our result, and let's choose our color. I'm gonna just copy this sequence. So you can also remove this if you want. It's just cosmetic enhancement of your graph. That's it. Nothing more. It just gives the color of your graph. So let's see what it shows. So this is the scatter plot that I'm seeing. So deep purple are the negative ones, and the bluish ones will be our positive. So if I just remove this, let's see what happens. Oh, now we are getting much more better results. So you don't need to use that sequence of varieties. So now our code has become very smaller. It's also easy to remember as well. So this is our negative section, and this is our positive. All the orange ones are positive cases, and it comes with all the troponin and CKMB data points. So you can see that negative cases, the troponin and CKMB has near negligible amount. In terms of positive cases, we are seeing the elevation of troponin and CKMB expression in patients. So that's the interesting phenomena that we are seeing from previous video. Now we can do some correlation heat map also. That would be also interactive. Let me show you in how to do that in Plotly. So for that I'll be using px.mshow. I'm gonna need the df core text auto would be true. Let's see what it shows first. I did a mistake here because we need to use df at num calls that we have already assigned for correlation, right? Because we cannot plot heat map on the whole dataset. That would be wrong because that dataset contains various categorical data as well, right? So we need to remove that categorical data, otherwise correlation matrix cannot be formed. So for that we are using df.nums. Here you can see we have already created this correlation matrix, so that's why we are using same function here also. Now let's run this, otherwise it would have been wrong. So this is the heat map that we are getting here. So we can see this is highly interactive in nature. Now we'll be doing some bar plot using plotly. Now for that I'll be using a group by function. So I'll be using a group by function using mean, that would be containing our result as a category, and I'm going to use multiple numerical column here. Troponin, and I'm going to call the mean here, mean for aggregation, and I have to reset the index here since we'll be plotting this group by. Now let's run this. Yeah, run perfectly fine. Now I'm going to use the fig and px as plotly, assign the bar, and data would be our mean df. So I'm using mean df for the data, and our x-axis would be our result, and y-axis would be our this list of numerical data. And now you can also define the bar as a group since we are using grouped data here. I think that's it. Now we can plot it using fig show. Let's see what it generates. So this is the data. This is the, I think this is the result, and this is the age. So these are the troponin and CKMB, and this is the positive result, and this is the negative result. So now if you just select one, it will be showing the only CKMB and troponin here. Now if you remove the CKMB and troponin also, your chart would be completely vacant. So let's put one by one. Here is the age, here is CKMB, negative, positive, here is the troponin. So that's it, guys. This is how you can generate the interactive graph using Plotly. Now we can do some statistical evaluation of this dataset using Statsmodels library and the SciPy also. So let's do that. Now I'll be starting this statistical evaluation with the SciPy. Since my system already has the SciPy installed, I am not installing the SciPy again. You can just install this SciPy library using pip installation, just like you have installed the Pandas earlier. So that's it, nothing is fancy. Now you can call this SciPy stats to import. So we'll be doing some chi-squared analysis. So I'll be running this chi-squared contingency, and I'm gonna do some crossstep table here. So I'm creating a table that would be using this crossstep function, which is an advanced group by using df gender. So I'm trying to get the statistical test between df gender and df result to check whether any significance difference is there or not. So for that I'm using this table to create a grouped data first. Now you can also print this table if you want. So let me show you what an error. Forgot to put the R here. So this is the table. Now let's move ahead. Now we can call this chi-square test, right? So we'll be using chi2 p and dof. So chi-square and p and dof are the degree of freedom, p value, and chi-square basically, and equal to chi2, let me just copy it, chi2 contingency. Now this will be containing our data table. So that's it. Now we can just print the each of this element first. So DOF would be our DOF, and that's it. Now let's check this. So this is the p-value that we are getting. So it is significant in terms of a statistical test because it is lesser than the 0.05. So I think you already know what p-value is. So if your experimental data coming lesser than the 0.05, which is coming here also, so that means dataset has statistical significance data. This is how you can run chi-square, and you can get the expected results over here using the expected. So let me show you. So we have to create a data frame for this. Create a data frame which will be containing the expected data, and I'm going to index the table index also, and columns will be our just like table columns. So table basically this table that we have already built. Now let's run this. So this is our expected data frame from chi-square. Now we'll be doing some t-test. So let me show you how to do t-test. This will be our t-test, and for age and troponin. So check whether any significant data is there between age and troponin. Let's check it. So here we'll be using from Statsmodel stats and weight stats, and I'm going to import t-test, that is independent ind. Now the age and troponin would be examined based on result, right? So basically we'll be doing some statistical test on age and result, and also the troponin on result. So there is two t-tests will be going on, so separately. So now let's do it one by one. So for that I'm going to need some groups, right? I'm going to use some positive groups. Positive group would be df result, which would be our positive in nature, since our result contains only positive and negative. So that should be our positive, and we can get also the negative group using the same df result, and this would be the negative. So that's it. We have created two groups for analysis. Now what we need is mean, right? So for mean we can do mean of age. Mean of age is highly required here. Mean age, that would be our positive, groups age using mean function, and also gonna need the mean age of negative. Let me put positive here, otherwise it would be hard to differ from one another. Now it will be showing the negative means of age. Now we can perform our t-test, and that's it. T-test would be p-value, containing would be p-value, t-test p-value, and I'm gonna use degree of freedom, which is known as t-free. And now I'm gonna use the t-test ind that I'm already imported from Statsmodel. Now we can do some positive age and also the negative age. I'm gonna use some use var, which is unequal and I can directly print the t-test. using T statistics. Let me just put it here, T stats here, and it will be showing me the T stat exactly. Sorry, I put the T test here wrong. It will be T stat. Yeah, and I can get the p value as well. P value. Now let's run this. Let's see what it shows. T stat is coming as 8.75. Now we can check this on our troponin level. Let's see what it shows. I'm gonna change the age with troponin. Let's change all the ages with troponin first. Tropo. Now let's see what it shows. Okay, p-value is significant. It is coming as a negative power of p-value. That means it is significant. And so you can check this on our CKMB as well. Let me check this out also. So I'm just removing the troponin from target and I'm putting the CKMB instead of it. Now let's see what it shows. That means our findings has some statistical significance. So we can conclude that troponin and our CKMB significantly differ from positive and negative patients. Now we can do some ANOVA also. So we've already done t-test. We've already done chi-square. Now the ANOVA is remaining. So we're going to do some ANOVA here. Now to run ANOVA, I'll be using our SciPy because SciPy ANOVA is very easy to do actually. So I'm going to use one way ANOVA here. So this if one way basically shows the one way ANOVA. So I'll be need some groups also here. That will be our positive and negative. Let me just copy it from here since I've already done the grouping of it, and let's do the ANOVA. ANOVA will be stat p-value. So we're gonna use the stat and p-value. Now for if one way would be containing our positive age and our negative age, and we can do some print. Print would be our abstract and print of p-value. Let's see what it shows. So p-value is highly significant. That means there is difference between positive and negative. So positive group and negative group, both the age are showing significant difference between results. So our statistical evaluation comes to a full chapter now. I hope you understand what we have done here. Now I want you to go through this video once more and try to solve this data problem on your own, and we'll meet into the next video. So see ya.